A private banking workload that reaches AWS services through a NAT gateway is using the wrong default path. For a bank, that design is hard to justify because it creates broad outbound egress, weak service level intent, and an unnecessary dependency on a public style path. The better pattern is private app to VPC endpoint to AWS service, so the workload reaches the service privately on the AWS network instead of relying on general internet egress. In this tutorial, I will break down gateway endpoints, interface endpoints, PrivateLink, endpoint policy, private DNS, gateway load balancer endpoints, and the EKS production pattern. A VPC endpoint is a private door from your VPC to a specific AWS service or approved private service. It is not a general internet tunnel. There are three endpoint families that matter here: gateway endpoints, interface endpoints, and gateway load balancer endpoints. The fast decision rule is simple. S3 or DynamoDB usually means gateway endpoint. Regional service APIs usually mean interface endpoint. Inline inspection usually means gateway load balancer endpoint. PrivateLink is the model that extends this private service access across VPCs, accounts, AWS services, and supported partner services without exposing a full network-to-network path. Gateway endpoints are only for S3 and DynamoDB, and that narrow scope is exactly why they are so clean. They work through route tables, not through endpoint ENIs in your subnets, so private workloads can reach S3 and DynamoDB without sending that traffic to a NAT gateway. Endpoint policy helps narrow what data paths are allowed through that endpoint, but it still needs IAM and resource policies around it. In a bank, use this pattern for private archives, model data, compliance exports, and any high-volume S3 or DynamoDB path that should stay inside controlled delivery zones. Interface endpoints create private ENIs in your subnets, so workloads talk to AWS services over private IP addresses that live directly inside your VPC. This is the endpoint family you use for ECR, Secrets Manager, KMS, CloudWatch Logs, SSM, STS, Private API Gateway Access, and many approved partner services. In production, place them in the availability zones where workloads run, attach restrictive security groups, and be deliberate about the set you actually need. From the application point of view, the flow is simple. Call Secrets Manager, KMS, or STS over TLS, but resolve and reach the service privately through the endpoint path instead of NAT. PrivateLink lets one VPC consume a specific service from another VPC or account without creating a full network bridge. That makes it ideal for shared platform APIs, tokenization services, security services, and approved partner integrations that banks want to consume privately. Private DNS makes the operational experience much cleaner because workloads can keep using the familiar regional service name while resolution maps to the private endpoint path inside the VPC. But DNS needs care. Be explicit about hybrid resolver design, regional endpoint names, and where private DNS should or should not override the default public name. In private EKS environments, nodes and pods often need ECR, Secrets Manager, CloudWatch Logs, KMS, STS, and S3. That is why endpoints matter so much. Image pooling is the classic example. ECR needs interface endpoints, but the image layers are backed by S3, so a strong private design usually pairs ECR endpoints with an S3 gateway endpoint. Identity and runtime access are the next reason. Pods call STS for credentials, read Secrets Manager, emit CloudWatch Logs, and may decrypt through KMS. Those are all better as private service paths. The production pattern is straightforward. Private subnets, endpoint coverage, In each AZ, minimal NAT only for true internet destinations, and a clear distinction between AWS service access and open outbound internet. Endpoint policy is useful, but it is only one gate on the path. It does not replace IAM, resource policy, KMS policy, or organizational guardrails. Gateway load. Balancer endpoints solve a different problem. They privately insert inspection appliances such as firewalls into traffic paths when the control model requires inline analysis. The mistakes are predictable. Single AZ endpoints, missing private DNS, forgotten regional STS behavior, ECR without S3, and NAT quietly left as the default for everything. The mature trade-off is deliberate service selection. Use the endpoints you need, keep NAT for true internet destinations, and choose the safer pattern where the business consequence of exposure is high. Keep the comparison simple. NAT gateway is for real outbound internet access. VPC endpoints are for private AWS service access. Gateway endpoint means S3 or DynamoDB. Interface endpoint means most AWS service APIs. PrivateLink means a private shared service. Gateway load balancer endpoint means private inspection. The bank-grade answer is this. In production, we avoid unnecessary NAT-based access to AWS services. We use VPC endpoints and PrivateLink, so private workloads can reach AWS services without traversing the public internet. If you want, the next lesson can go deeper into endpoint policy design, private EKS networking, or centralized PrivateLink service patterns across multi-account AWS estates.